Hello legends. In this video, I'm going to give you an introduction to relational databases. I'm assuming that you're someone who is building apps and automations by using AI, and that you might not be a traditional developer in the sense of you didn't go to get some kind of formal education, or you don't have much experience in development in general. So then sometimes these kinds of concepts like relational databases might not come intuitively to you, but these are extremely powerful and can be very useful for your automations and your apps. So I'm going to take some time to actually introduce this to you and teach you how to use it. My goal is that by the end of this video, you will understand what a relational database is. So the different components that make up a relational database, like what makes it special and unique compared to a different database. What is the purpose of a relational database? So we'll kind of look at what's the reason it was built and what are some benefits that you get from using it. And then we get a little bit more practical with question 3 when we start looking at when you should be using relational databases. So we'll compare when you're building out automations using no-code tools like NAN and what the purpose and value of a relational database is here. And then we actually have an example where we're building out a to-do app where we sequentially build out a database and we see how the database actually enables more functionality for the app that we're building. And then for the final question where we look at how do you actually build one, I've set us a challenge to design a relational database that tracks customer orders with products. This will be a simple mini project that we'll complete in this video to help solidify our understanding of all the stuff that we've learned. Okay, so let's start by answering the first question, which is, what is a relational database? So a relational database is a collection of tables where data is stored in those tables in a tabular format, where each table has rows and columns, and each row represents a single entry, for example, a customer or an order, and each column represents an attribute of that specific entry, like a name for the customer, the email of the customer, or the price of a product on an order. So looking at this visual over here, we can see that the table itself is outlined in pink. And within the table, we have these rows and columns. So each row is a record, and a record is just a single entry. So in this case, this is a team's table, and it contains information about a team. So we have the Red Bull Racing team entry over here. And then we also have different columns which have different fields, and each field is an attribute of that specific entry. So in this case, we have the team name attribute. For this record, it's Red Bull Racing. And then the driver 1 attribute. So Red Bull Racing has a driver called Albon. And then the driver 2 attribute. Over here, the second driver for Red Bull Racing is Verstappen. So continuing on and looking at more characteristics of a relational database, we have that each table in the relational database contains one entity of information. This means that you would have a users table, which is separate and distinct to the products table, which is separate and distinct to the orders table. But there would actually be a relationship between each of these tables, and that relationship would exist by using these different keys, a primary key and a foreign key. So this basically means that you wouldn't just create one table that contains like that each of the columns would be, a users column and a products column and an orders column. That's not how you would actually store the information in a relational database. They would all be separate tables that store that specific information. And then there's a relationship between certain records in these tables. And that relationship basically shows you if you want to make connections between data. So to understand that a little bit more deeply, we can see that we have a primary key and a foreign key. So the primary key, the purpose of the primary key is to uniquely identify each record within the table itself. So if we zoom into here, we have an employees table. In this table, we can see that has first name, last name, and department information per employee. And then over here, we have the primary key. The primary key is responsible for maintaining the integrity of data within this specific table. So Anna has the employee ID of 1, Christine the employee ID of 2, and Thea the employee ID of 3. If I wanted to add another record and I wanted to reuse the employee ID of 1, and then, for example, assign it to myself, which is Bart, that record wouldn't be able to be placed into this table because the integrity of the data would be broken. So the primary key's role within the table itself is to have a distinct value for each entry. And then if we go and look at the foreign key, the foreign key connects related records across tables. So now if we want to look at a separate table which contains the sales orders, we have over here the customer ID, so the unique ID of the customer. We have the order total of $422. And then we have the salesperson that's responsible for actually facilitating that order. So in this case, we come to the primary table, which contains the primary key. And we would actually just take the primary key and use it in the foreign table. And this is now known as the foreign key. So in this case, we have this specific record. So customer ID of 001, order total of 422 and salesperson ID. So in this case, it's going to be Thea who is responsible for that first order. And then if we go down the table, we can actually see that the second order here that's been placed, the salesperson ID is 1, so that's Anna. And then over here, the third order that's been placed has the salesperson ID of 3 once again, which means that Thea is actually been placing multiple orders for our business. So this example will help us solidify that understanding a little bit more. We have two distinct tables. The first table is the students table, which holds the name of every student that's enrolled in our courses. Then we have the courses table, which holds the information of every course that we offer. And then in the middle, we have a related database, which contains each student's information, so the student ID, and then the course that they're taking at our school. So if we break this down a little bit more, this first column here is the primary key of this specific table. So the students table, we have Sam with the primary key ID of 1, Mary is ID 2, and Tyne is the ID of 3. And then looking at our courses table, the primary key is over here. So we have SQL is ID 1, ASP is ID 2, MongoDB is ID 3. Now, in both of these cases, this and this is the primary key because it serves the purpose of making each record unique within that specific database. And then once these primary keys are taken to this foreign table, they now become foreign keys. So this over here is the foreign key of this primary key. It's the student's ID foreign key. And then this one is the foreign key from the courses table. So this is interesting because it shows us that the students table and the courses table, if they're stored independently like this, there's no actual relationship between them. We just have a table of students and a table of courses. Once we get the relationship into a separate table, where we're pulling in the IDs as foreign keys, we can now see what each student, like which course they're enrolled in. So in this case, we've got these 3 entries, which are the exact same person. In this case, this is Sam. So we can see Sam over here. He has the ID of 1. Sam's enrolled in course 1, 2, and 3. So in our case, we can just look at this table over here, and we can see that Sam is enrolled in the SQL course, the ASP course, and the MongoDB course. So now if we go across to ID 2, we can see over here that Mary, who has ID 2, is enrolled in course 3 and 4. So she's enrolled in MongoDB and Java. And then finally, looking at the ID of 3, which is Tyne. Tyne is enrolled in course 3, which is MongoDB, and then course 5, which is PHP. So just to make a quick distinction, this information here is going up in ascending order. This is not a characteristic of a relational database. The entries don't have to go up in ascending order. If I wanted to add another entry for Sam, for example, I would just add another column over here, and I would put number 1 for Sam to denote this is Sam and he's taken another course, which let's say I put 5, Sam would be taking PHP. So this is just so it happens to be like this for the example. It is not a characteristic of relational databases. Now moving on to understanding the purpose of a relational database. So one of the questions you might have is, why don't we just use one single table to store all that information? Why do we actually have to split it into separate tables? So on the left-hand side, I've got a comparison of using one table, where in this table we're storing information about orders, then information about products, and then information about customers. So hopefully you can see those distinctions. We have order information, product information, and customer information within one table. And then on the right-hand side, this is the relational database. We're actually storing 3 different tables, one that contains customer information, one that contains product information, and one that contains order information. So I'm just going to explain to you some of the challenges that you run into if you use one table to store all those distinct bits of information. So the first issue is that we've got a lot of repeat data, and the repeat data adds to bloat and slow queries. So over here we've got just a snippet of a database where we have 2 entries. Bart's placed an order with order ID number 1, and he's placed an order with order ID number 2. So in this case, we have 2 entries where Bart has, we've double stored his name, and we've double stored his email address. For a small database, it doesn't really matter. But if we had, let's say, 1,000 records, and in those 1,000 records, Bart's placed 50 orders with us, well, now we've double stored his name 50 times, or not double stored, we just stored his name 50 times, and his email address 50 times. So if Bart ever wants to make an update to some information on his account, like change his email address, we now have to make 50 requests to the database to actually make that change, even though it's just for one customer. So it kind of seems a bit counterintuitive to do that, and that's what actually adds to the bloat. So we have the unnecessary double storage of information, and also slower queries because we have to send multiple and multiple requests just to change information for one user. Now, since we're storing all those separate entities of information in one database, if we ever want to add a product, we actually can't do this without adding an order first. So in this case, just to recap, we've got order information here, then we have product information here, and then customer information here. Now, if I ever introduce a new product to my lineup and I actually want to make it somehow visible on my website, let's say. So if I've only got one database that stores all my information, well, unless I have an order already placed for my product, because this is a requirement of my database, I have to relate it to some kind of order ID. Unless I have an order already placed for the product, I cannot add it to my database, which means I either have to fudge an order and just make something up, which is not what I want to do. That's going to impact the integrity of my database. So now I'm actually forced to add some kind of order. So you're in this bit of a pickle situation here. Same thing if you want to delete some information. So let's say Bart wants to delete his order. So in our case, let's say he's just created one order and he's already realized, actually, this is the wrong timing. I don't want to place this order now. So if we go ahead and delete Bart's order, we're actually wiping out all the data that is related to Bart's account. So we might just really only want to delete the order ID, but we don't actually want to delete Bart's information for Bart and his email address. We might want to use this later on to retarget at him at a better time. So we might actually be able to win back this sale. But since everything is related, so if the order ID is wiped, if that order is deleted, so is his record and his information, and we'll never be able to get this back. So hopefully you already see now from these two examples of we have to add product information. We can't do it because it's related to an order. So that actually would make it better to split up that information of order into a separate table than the product. And then now if you want to delete an order and you don't want to lose customer information, you'd actually want to split up the order information to be separate from the customer information. So now if we look at that same example, but now built out in a relational database where each of those entities of information are stored separately. So just to give us a recap, we have a customers table, we have a products table, which is distinct and different to the previous table, and then an orders table over here. So in this case, if we ever want to update some information for Bart, like let's say Bart updates his email address, we just have to come into this table, we have to edit his email address over here, and if Bart's got 50 orders or 1,000 orders, it's still one request to our database, not 50 or 1,000. So there is no extra bloat, and it's a lot faster as well. And then also if we have the issue of products existing independently to orders. So if we want to add another product to our database, so actually introduce a new product and get that proliferated through our website and all the different avenues, we can just come into this database over here and add that product. And it doesn't actually have to be related to an order in order for us to add it to our database. And then the same thing with the orders. So let's say we place an order for a customer and it turns out they want to delete that order. Well, we actually still retain their information because they were added as a new customer into our customers table. And this is distinct and different to the orders table. So hopefully this shows you why it's actually better to split up the data into different tables. It lets you actually change the data. So you're able to make updates to your data without actually breaking things. Later in the video, we'll be looking at an example of actually building out one of these databases. And we're going to see that it's very easy to also add additional data into our database. So when everything is in one column in one space, there's a lot of things that are relying on each other, and it makes it very difficult to make changes and updates, remove things, add things. So there's actually a lot of freedom that comes with splitting things up into separate tables. So one thing I want to touch on very quickly is the querying of data with SQL. So SQL is structured query language. It's essentially the ability to create relational databases, add records, remove records, edit fields, rows, columns, all that kind of stuff by using code. It's a very easy way and it's a very uniform way to actually work with this data. So relational databases and SQL go hand in hand. I'll touch on this in a separate video because there is a lot of information that goes into this topic. But one of the other benefits of relational databases is that before you had relational databases, data typically was stored in hierarchical or network databases. So this is like, imagine folders on your computer. As you can imagine, the way that you set up your folders on your computer is very personalized, and it's not necessarily a uniform structure that's shared across multiple different businesses and industries. So a relational database, it was introduced as a way to actually structure all that data, so that the data that's stored between different businesses and different industries, there's actually a uniform way to store it and work with it. And when I say work with it, I mean querying it, like creating databases, adding records, removing records, all by using SQL, the structured query language. So the main value is that now when you use relational databases, you can use SQL, and this basically means that anyone could work with your data. So if you hired some external engineer, some analyst, or someone to come into your team and actually work with the data set that you have, they didn't actually have to go around and learn your personalized schema of your hierarchical or network-based database. They could just use SQL, which is a structured language, and they could use a relational database which follows a uniform pattern. And if you haven't played with SQL just yet, then that would be great for a follow-up video. But it lets you query things by just describing what you want. So it's not actually just describing in plain English, look at what I'm doing here, but this is essentially what you're able to do when you have storage of all your separate entities of tables that store orders, products, customers. You're able to query things like which products did we sell most of in January? How many orders did Bart place in the last 12 months? What are the top 3 selling products? This kind of stuff is very easy to query in a straightforward way. And if you are interested in learning about SQL, just comment below so I can see how much interest there is and I can make a follow-up video. And then another benefit is that you have data integrity. When you're building relational databases, it's best practice to actually have a primary key within each table, which is what we discussed over here, where each table has a unique identifier for each record. And then we were able to use that primary key, insert it into a separate foreign table, which is now known as the foreign key, and we're able to make relationships between different types of data. So in the earlier case we had over here, we had a list of all the students, a list of all the courses, and then we're able to see the relationship between students and courses and see what everyone was taking for this semester. Now there's a bunch of different benefits that you get when you're working with relational databases. We're not going to be touching on all those different concepts and best practices in this video. I think it would just be a little bit too heavy to do that. So I will make a follow-up video later where we're speaking about these concepts and also about using SQL to just start building a more holistic view of working with relational databases. But it's very important for us to know that when you build out these kinds of systems, you maintain your data integrity. So that's just a fancy word for saying that the data that you have stored, you can actually trust it and you can use it. So that's really important when you want to make data-driven decisions, that you can actually trust the data that you have, that it doesn't have incorrect values, that it's properly assigned. And yeah, if you're working in a business, this is very important to you. So then over here, we have a summary of the benefits. This one we're actually going to be seeing in just a second for a practical example. But let's say for this example over here, where we're storing customer information, product information, and order information. When we've got all of our database where it has all these separate entities are stored as separate tables, it's very easy for us to come in and add a new table to store different bits of information. Like if we want to now get tracking information, if we want to now monitor reviews for each order that was placed, we can actually just come into here and not mess around with any other data that we have. We can just add a new table and just start building relationships with the different data that we have within our table already. So that's what this first point is talking about, just adding more tables into your database. The second point is speaking about using SQL, so structured query language, to actually query the data in your tables. So SQL is actually very, very cool because you're able to pull information from multiple different tables and then analyze it by aggregating information, by looking at relationships between different data sets. So the stuff that you do here for like data analysis, this is super, super important. And then finally, we're looking at enforcing rules automatically. So by using some of those best practices, by using some of those concepts, for example, like foreign keys, we're actually able to ensure valid relationships between different tables that we have. Okay, so now spend some time thinking about when we should be using relational databases. So if you're an AI builder like me, you're most likely building out automation using tools like NAN, or you're building out apps for yourself using tools like Replit. So in the case of automation with NAN, you might build a relational database for reporting and analytics. So in the case of automation, NAN actually already does this for us in the backend. So if you go to your editor, into your actual workflow canvas, and then you click on executions, on the left-hand side here, you can actually see a bunch of historical executions of your workflow. In the backend, NAN is actually storing all the separate information for your workflows for you. So they have a table for workflows, they have a table for execution. So an execution is every time your workflow runs, you actually log the events. They'll have a table for all the nodes, and then the nodes are actually by relationship into your workflow. You're able to see what your workflow consists of. And then it might even include all the credentials. So in our case, if we want to look at executions, we don't need to know what kind of credentials are stored within our workflows. But this kind of database, you can see that there's multiple relationships between these different entities. Each entity stores its own individual thing. And then in the case of NAN, you're actually able to go into your executions once you click one of these things, what's happening in the backend is there is an SQL command that's hitting all these different tables and bringing in the information, aggregating it, and then you can actually display the information, in our case, as a historical execution, or in the case of building portals or dashboards, you can actually aggregate results and you can see, for this period of time, there were 1,000 executions, 80% of them failed, 20% of them passed. Let's look at why. So then we see for the example of NAN, the relational database is actually built and it's used for reporting and for analytics, or also for debugging workflows. And then we're going to be looking at this example in just a second as well, but if you're building out AI apps or dashboards or portals for yourself, then the relational database for this case actually can help extend the functionality of your front end. So we'll look at this in just a second. But before we do that, let's quickly look at some other examples of relational databases in different apps. So let's say we're looking at the CRM or contact manager. So in this case, we have a database which contains a table of customers, interactions, and sales reps. So this is every customer that's interacted with our business. We list them over here. Every interaction with the customer, so an email or a phone call or an SMS is listed here. And then the sales reps, so the staff that are responsible for trying to get these customers from the lead to the closed status. We're listing some relationships between these tables over here, and the purpose is to see every conversation or sale tied to a specific customer. So if you wanted to rebuild HubSpot in a very, 1 out of 10 way, this is how you would start. This is the type of structure or tables that HubSpot has in the backend. So now looking at something like the e-commerce store example, the tables are products, customers, orders, and items. So every product this store has, every customer that's been interacting with the store, the orders that were placed by the customers, and the line items, so all the items within these orders. So the relationships are listed here, and then you might be able to pull out reports like the top 10 customers by total spend, or the most products that were sold this month. So if you wanted to build something like a Shopify, again, this is a very level 1 out of 10 example, but this is the backend that these giants are actually using, like multiple different tables. And then by storing all the information, all the small, minute information, you're able to make these relationships and actually pull out this kind of data analysis. Another example is an appointment booking system where you're logging all the clients that have interacted with your business, all the staff that you have, the appointments that were set by the clients and fulfilled by the staff, and then the services that your business offers, where each service might be tied to a staff member that actually, does that service, and the clients, and, for each appointment, which service did they use. So you can see how this information is now kind of starting to stack up. You can store all independently, and then you can easily query the database and see which staff have bookings this week, so which ones are actually available to take on more work, or how many massages did we book today. And then our final example, like a school or course platform. So a list of all the students that are enrolled in the school, a list of all the courses that the school offers, the enrollments, so I think like, which student is taking which course, and then the list of teachers, so like which teacher is teaching which course, and which teacher is responsible for which student as well. So as you can see, like it's kind of like when you get your head wrapped around this, it's not super hard to start thinking of building out separate tables for separate entities, and then figuring out how all those tables are related. And that's when you can start using things like primary keys, which we know are for distinction of rows within the actual table, and then foreign keys, which are for relationships between different rows, between rows in different tables. So yeah, once you kind of get your head wrapped around this, it makes working with relational databases a lot easier. And then over here you can see a list of all the students in a course, or all the courses a student takes. So now I'll take a look at how to actually build a relational database. So we actually covered a lot of ground here. We've looked at what is a relational database, what are all the different features of a relational database. We also spoke about why it's better to have multiple distinct tables as opposed to just one massive table. So now let's put a bit of this theory into practice and just start kind of cementing all this knowledge in our brains. So the first example I want to look at is actually listed as example 2 in my slides, but I think it's going to be better to start with this example. This is going back to that to-do app. So I want to come back to this example of a to-do app. So really I want to look at, I think a lot of us have seen a lot of examples of creating to-do apps, like the visual interface. Every time a new AI tool comes out, someone's making a video about it, about how to do a to-do app. But really, I think the front end might be easy to make, but the back end is actually what's most interesting for me, because all the functionality on the front end, adding tasks, deleting tasks, if you want to add new users, if you want to assign tasks to someone else, if you want to add a folder system where you can, group tasks together, all that kind of stuff is only possible by having a database in the backend to support that functionality. So let's take a look at the progression over here. Okay, so let's start by looking at the basic example of an entry-level to-do app. So we have the ability to add a new task, to list the tasks that we have open, and then an X to close that task. So that's facilitated by this table over here. So it's very simple. We don't actually need multiple tables for this database. We have the task ID, which is the primary key. Once again, the primary key is the distinct value that's given to every single record or row within our table. We then have the task name, so clean room, and that's the name that we see here. The description, so if we double click on this task, we might get a pop-up that has a description of the task. Then we have pending over here, and maybe pending is the reason why this task is visible. And if we set this to complete, that's how we manage the state of the task, and maybe that means we just delete this task then. It's not visible anymore. Maybe that's what happens. So very basic functionality, and if you want to add a new task, you click this button, and that just adds another row into here, and maybe it makes a pop-up, and you can see from the pop-up what name do you want to give to this task. So clean garage, what do you need to do, sweep the floors, and then it just makes it automatically as pending, and then it pops the task up over here. So let's say this says clean garage. So that's how the actual functionality of the task to-do list actually works. So very basic example, but we can see one table gives us a lot of juice for the actual app. But now let's say we want to add some functionality. Let's say we have a lot of tasks and we want to add some folder functionality to this app. Well, now for us to actually add the functionality of adding folders, it's not so difficult. So over here, let me just make sure you can see all this stuff. I've just added another table into our database, and I've added a primary key, which means that every single entry that I put, every single record that I put into this table is unique, and I've used 12001. I've also taken this primary key from the task table and I've related it to the folders table over here. So that's now the foreign key. So primary key over here and foreign key over here. So now I have a relationship between tasks and folders. So I can now start grouping tasks inside folders. I might also have some other characteristics like folder name, it's cleaning, and then folder status is live. And the same thing, maybe it's live or maybe it's archived, and if it's archived, we'd actually see the folder. So the status is a really good one. One thing I actually haven't put here is stuff like date or due date or stuff like this, but I think you get the picture. So if we just zoom out a little bit more, what we start looking at now is at the old style of the app where you could add new tasks and list tasks and then close tasks. With the folders table, you now have the ability to add a task. Actually, I suppose you should also have a button here for add folder. And let's just make this light blue. But now you have more functionality. You can add a new task, add a folder, and then you can start grouping tasks within folders. So if we created another task over here, we'd be able to assign the actual where that specific task goes to by then adding another relationship over here. So this is just a very simple way that we didn't actually have to do anything to this specific task table. We just added a new one and we have some more functionality. And that means on the front end, we get some more, we can actually do more things. So there we go. That's the updated view when we have the folders table. And now I also want to upgrade the experience to have multiple users. I want to have the ability to assign a task to someone and have someone assign a task to me. So that's what we've done over here. So we can see our original relational database had tasks and tables, and now we've added one more table into the relational database, which is a users table. So let's break this down. We have our primary key, which is the distinct unique ID for the record within this table. We have the folders primary key and the user's primary key. So that's best practice. Every single table has a primary key. We then took the task ID here, which is the foreign key. We took the primary key from the task table and converted it into a foreign key in a folders table. This gave us the ability to actually group tasks inside folders. And then we also put the task ID into the users table over here, which means that the primary key from here is now the foreign key for the users table. And this gives us the ability to actually assign a task to a person. In this case, I wasn't super clear. Maybe I should have said task ID owner of the task, because you have the assignee or the owner. So there's a bit more nuance and complexity that goes into here. But that's how you can actually see where you have the ability to actually increase the functionality again. So a really cool thing I want to look at is this stuff over here. So yeah, this front end is getting a little bit messy and hard to understand, but we can add a new task. We can sort by user, we can sort by folder, and then we can see, all of Bart's cleaning tasks, and we can kind of list them over here. So what you might have seen, what you definitely would have interacted with on different apps that you're using is like the filtering mechanism. So if you've ever seen something that says like filter by date or filter by user or filter by whatever category, this functionality is basically running SQL commands in the backend to all your databases. So if you want to filter by user or folder, you're running SQL commands across to your folders table or your users table. There's a bit more complexity than that, but that's how you're able to then change what you see on the front end. It's just these queries that you're really displaying to the user. You can filter by due date, which I didn't actually put into our tables. You can add a login, you can add separate views. So one really common thing that you might want to do if you want to build an app and you want to start scaling it, or you want to build an app for your business and you got 100 employees, how do you actually manage the experience of each employee on your one single app interface? Well, if you add some functionality for the user to actually log in, then you can take the user ID, for example, and then you can make that the actual state of the app, just a high level kind of principle to speak about. And then what that means is that when the user is signed into their account, they're only seeing their own related tasks, their own related folders, and all the tasks that have been assigned to them. So once again, this is all relational database stuff. This is probably a little bit too complex or advanced for us to kind of really touch into today. But that's one of the ways that you can actually manage the state of your app. So you're able to do this like login and customize views and customize experiences for staff, for customers, for yourself. So now for our final example, I've got a task for us. I want to create a database that allows me to track which customers order which products. I've also given us a hint where we have to actually build a relational database with 4 tables where we have the customers table, the orders table, the products table, and the order items table. So I've copied this across to a Google Sheet. This is a little bit funny because we're going to be building the schema of a relational database, which has multiple tables within one sheet in a Google Sheet, which is just like one table. But anyway, so we've given ourselves a hint where we have to create 4 different tables and figure out the relationships between them. So we have the first table here, which is the customers table. And for our customers table, as we know, we want to create separate tables for separate entities of information. So the customers table, as we know, the first thing it has to have is the unique ID. So let's say it's the customer ID. This is the primary key for our customer table. And then along with the customers table, maybe you have something like the customer name, their email address, whatever other identifier information that you want over here. But let's say for now, this is all we want to look at. So I've actually got in this next slide a database that's already been built out for us, a relational database, which we're going to go to in just a second. But for this first part, I just want to focus on getting some of these basic concepts right. So let's get this database like this. Okay, let's build it out. So we have the customers table, and this is going to be our primary key, so PK for primary key. Now we have the orders table. Okay, so orders table over here. The first thing we need, as we know, is the primary key, so the order ID. The order ID is not the Shopify order ID, for example. That could be, here. Shopify order ID, whatever you want. The order ID, just to make the distinction, is the unique ID for this table itself. That's the primary key. So let's say we have that, the order ID. Well, we know that for the order, we have to somehow relate it to, what does an order contain? It contains information about the products on it, the prices, also the customer who purchased the order. So right now we have the customer ID that we can actually put into here. So just looking at this, we have the primary key, the unique identifier for this entry, for this table itself, and then the foreign key, which for us is the customer ID from here. Let's make this in light yellow, and now the customer ID is over here in light yellow. So I think that's enough for now. Let's kind of expand this out, make the app like this, and put this in the middle. So okay, there we go. We have the customers table. We have the orders table as well. Now the next one we need is the products table. Okay, so products table. And the purpose of the products table is just to list all the products that our business offers, not actually products related to any orders just yet. So in this case, the products table is going to have a unique product ID. Again, this is not the SKU of the product. That's got a different purpose. In this case, it's just the product ID, the primary key, which is the unique value that we're giving to this specific record in this table. So we have the product name potentially, and then we have the product price or whatever other descriptor that makes sense for the database that we're building. So let's put this into the middle. We have the product ID is the primary key, and actually that's enough for us for now. So now let's close this, and then the final thing we want to have is the line items for the order. So one thing that we'll touch on just a little bit later is, like, you might be asking me, Bart, why can I not just have products and then I actually list all the products that we have? So product 1, product 2. Why can I not do this? Well, later on we're going to be touching on this, but there's actually these concepts that are related to building relational databases. One of those is that you want to build atomic tables where you're not actually putting multiple values within one cell. It's just one value per cell. So we'll speak about this in just a second. So let's just delete this. So for our case, the order lines table gives us the ability to actually just list the orders here as they are, and then in the order lines, this is where we actually do the quantities of the products, the different products that were on one specific order. So let's go to order lines table, and for this, some of the stuff that we need is, like we know, the order line ID. So this is the unique ID for this table. This is the primary key. Now we know that the order lines are going to be related to something. So in our case, let's just make this. The order lines are going to be related both to a product and to a order, because the order line has to contain information of which order it relates to. So we have the order ID, which in this case is the foreign key. Let's just add some coloring into here. So orange, and then order ID here is orange. And then we also need to know which product it was. So for the order lines, we have to know which order the order line relates to. And we have to know what product is on that specific line. Like these are the two relationships this table has to have. So then we have the product ID. There we go. And this is the foreign key, and foreign key because it's primary for another table. So the product ID, let's just add a different color. It's going to be light green, and let's add the product ID color here as well. So the interesting thing is that for a table like this, like, we're just seeing the order line ID, which doesn't give us information as a human on our front end, not too much information. Same thing with the order ID, same thing with the product ID. But if you were to actually trace this stuff back, you'd be able to see that this order line ID relates to this specific order, which relates to this specific customer, and same thing with this product. You can trace it back to this table, and you can see that the product relates to this specific name, to this specific price. All right, so we're now in the examples sheet, and I've just taken those 4 tables we built out and just put a little bit more structure and neatness to them. So over here we can see these 2 tables. We have customers and products. The distinction here is that these guys don't actually have any foreign keys. So this is interesting because the customers table just holds a list of all of our customers, and the products table just holds a list of our products. But then when you get to the orders table, this is where you have to make these external relationships. So the orders table, it has to be related to a specific customer. That's why the foreign key is the primary key from the customers table. And then the order items table, so all the products that were on that on specific orders, that has to relate both to the order ID and the product ID. So actually for this table over here, we're just bringing in information from the customers table. So we have the order is related to a customer. And then for this table over here, we have to bring in information of the specific order and then also of the specific product. So I've got some examples where I want to start filling out some information for us. So example 1 is I want to fill out information where Bart orders 1 pump for $299. So how do we actually put this information into our system? So let's say we have the customer ID. I want to add a new customer called Bart. I'm just going to go 11001 as my convention. And I'm going to put the name here of Bart. And email address I'm going to leave empty, and address I'm going to leave empty because it's not important for us right now. So Bart orders 1 pump for $299, which means I also have to add a pump to our products table. So I'm going to go 12001. Product's name, this is going to be pump. And the price is $2.99. There we go. And description is just, whatever, not important for us right now. So now that I have the customer in my customers table and the product in my products table, let's actually add an order. So for order, let's go with the convention of 13001. The customer ID is going to be taken from here because it's the Bart customer. Now our order date, let's just leave that empty for now. And then the total amount of the order was Bart actually purchased just one item, which is $299. And now for the order items table. So as you can see over here, we don't actually know which items are on the order, but we do know that Bart placed some order. So what we have to do here is add the order item ID. So I'm just going to go with 14001. And for my order ID, I need to take it from here. So that's the primary key, moved in as the foreign key. For the product ID, now actually building the contents of that order, I'm taking the pump and bringing it into here. And the quantity was just one because Bart ordered one pump for $299. So that's actually how we build out the actual record into the database. So now our second one is Steve orders 2 showers for $199 each. So let's add another entry here, 002. This is Steve. And let's just leave this information because we don't really care about this right now. 12002. And Steve orders was a shower. And the price was $199. Let's put it into here. And description, we just leave it empty for now. Now for our orders table, so we've got Steve added in, we've got the shower added in. So now we have another order placed by Steve. So I'm just incrementing up here, 13001 to 13002. And we have to pull in who this order relates to. So it actually relates to Steve, which is this value over here. Order date we'll just leave. And what did Steve do? So he had actually 2 showers for $199 each. So in this case, the total order amount is $199 times 2 times 2. So it was $398. So this is the aggregated total. And then finally, for the items that were on that order, let's put our next primary key, so the unique value for the next order line item. The order ID relates to here. So we have order ID 13002. So this is Steve's order. We know it's Steve's order because the relationship here. We have the product ID, which is from here, 12002, and the quantity that were purchased was 2 showers by Steve. And there we go. So now we've actually got both of our orders entered into our database. And the final one is Bob orders 1 pump and 1 shower. So let's go into here. We have to add Bob, 11003. Let's add Bob into here. We'll just leave these as empty. He has 1 pump and 1 shower. We don't actually have to add any products into here. And we have order ID. So let's just go next number up, 13003. Customer ID is from here. Primary key pulls in as the foreign key. Order date, we don't really know for now. And he purchased 1 pump and 1 shower, so equals $299 plus $199. That's the total order value over here. And then we have what items were on the actual order. So this is going to be interesting because we actually have 2 distinct line items. So 14003 relates to the order ID of here, which is for Bob. And then we have product ID, which is firstly he purchased a pump and he purchased 1 quantity. And then we have the next order ID. Be mindful of this. The primary key is never duplicated. So this is fine for us to do because it just defines this is a distinct value. What we really want to match on is the order ID. So the order ID is going to be repeated over here. So now if we ever do our SQL query, we can actually see that these are 2 distinct rows, 2 distinct records, but they are shared by the same order. So now the product ID is the shower, which is 12002. We bring it into here, and the quantity is 1. So now we've just placed those 3 orders into our databases. 3 customers, 2 products, 3 orders on our table, and 4 separate entries into our order items table, where we had dynamically 2 quantity, and then actually 1 order that had 2 separate line items. So this is, maybe if this was a little bit complex for you to understand, just rewatch this section again, or just build out this exact table in your own Google Sheet or whatever platform, and just have a go doing this. It actually gets pretty interesting and pretty fun, even if you're doing it by yourself. And let me just show you the rest of this over here. Sorry about that. I had it covered off the entire time. So now one of the really cool things you can do is actually run an SQL query for something like, show me all the orders with customer names and product details. So in our case, we don't actually have a view or a table that shows us all of the orders. from looking over here, we can see that we have a bunch of distinct tables, but none of them actually show you every single order with the customer information and the product information. So what we would actually have to do is run a SQL query to pull out that info. So I actually haven't included Bob, sorry Bob, but you can see here customer name is Bart and Steve, the order date, the product name on that specific order, we have the quantities, the prices, and the line totals. So this is how, if you are doing some kind of business analysis on your own information, or if you're using Shopify and you're running those custom queries in the backend, they are using Relational Database and SQL. I'm actually not sure if Shopify uses some like their own proprietary backend information, like query language or whatever, but I would just assume they probably use something similar. So the beautiful thing is that you can actually generate any view or any report by using these SQL queries. So even if the data that you're storing doesn't, you don't have a table for that information, the point of SQL is to actually build these views, build these tables for you by just, running into different tables and actually aggregating results and bringing things front and center. So this is a really cool thing you can do with SQL. All right, guys, so this brings us to the end of the lesson. I really appreciate you sticking around and actually watching through and learning along with me. If you did, learn something new, if you enjoyed this type of content, I'd love it if you could actually like the video, subscribe to my channel, drop a comment below if you want to see more, like a continuation of this course. There's a bunch of stuff that we can learn. We can learn about some of those other best practices and concepts when we're building out these relational databases. For example, there's this thing called normal forms, which are just rules or stages to help us with data integrity. So that's one thing I promised that we would look at just a few moments ago. So the first normal form, 1NF, is that each cell contains only one value. So this is the atomic way of building out relational databases so that each record is unique. So over here, we've got an example of a table which contains the customer ID, so the primary key, the name, and then for the phone number, we've actually got two different results. So we've got the primary phone number and a secondary phone number for this customer. This is actually not allowed under this rule because if you're doing SQL commands, SQL commands, you're returning the contents of this cell. If you return the contents and there's multiple different values in here, you actually have to parse those values further. So this actually brings us away from that structured format of interacting and building out these relational databases. So what you actually want to do is you want to split up those values into separate entries. So over here we had the first entry and over here we had the second entry. So if we query this using SQL, we can always be sure that each cell only contains one value. So the word atomic comes from the word atom, which is the smallest possible thing, smallest possible value. And that's the concept, that's the approach, that's the best practice that we want to follow when we're building out these relational databases. So there's a bunch of these that we have to follow when we're building out databases. So yeah, we can actually do a lot more learning in that space. So why do we want to do this? It's because it keeps our data clean and consistent. And also because it makes SQL queries simpler because you don't actually have to split text or arrays. So if you're storing complicated bits of information in here, you don't have to do any additional processing. And on that note, how do we do SQL querying? So like how do we use SQL for querying our relational databases? So, we've just done all the heavy work of actually building out a relational database. We've now collected a bunch of different records. What's some cool analysis that we can do on the information that we have that'll help us with business decisions down the line? So this would probably start off by just being an introduction to SQL, how to use it, how it works, just getting our hands on a steering wheel, going for a bit of a test drive. And then another learning we could do is building out a real life relational database. So like having a project, which is one thing that I have in my school community right now. I've got a project where I'm building out an app, and as part of that, the first stage of building out the app is looking at how does the front end work, how does the relational database need to look to facilitate the functionality of the front end. So there's a lot of cool stuff that you can do. And once you know how all these different systems, these separate systems all work together, just like we saw with separate tables coming together for our database, a lot of magic can happen. So if you want to keep learning more about this kind of stuff, please comment below, please like the channel and subscribe. All right, thank you guys, and I'll see you in the next one.